Okay, so this is the multiple choice exam from January 2011, so let's get stuck in straight away. Got a railway truck X travelling along a level track collides with a stationary track Y and move off together with the same velocity. Which line describes how the total momentum and total kinetic energy of the truck changes as a result of the impact? So first thing is there's no external force acted, so the total momentum has to remain the same. So we can eliminate anything that suggests otherwise. And then we're looking at this one. Have we been given any extra data? No, we haven't. Are we told if it's elastic or inelastic? No, we're not. So in ordinary circumstances, you would lose kinetic energy as a result of a collision, so you go with option B. Ooh, that's the end of the page. Okay, question 2. Got a disc diameter 120 millimeters, and it turns about at the center. It's turned through an angle of 30 degrees in 20 milliseconds. What is the average speed of a point on the edge of the disc during the time? So first thing, we need to get what the angular speed is. So it did 30 this many radians in this many seconds. So let's calculate that before we're going to convert that into velocity. So 30 divided by 180 times by pi divided by 20 times 10 to the minus 3 gives us 25 over 3 pi. And velocity is r omega. The radius is 60 millimeters, so that's times 60 times 10 to the power of minus 3 gives you pi over 2, which is option A. Okay. A particle of mass m moves in a circle of radius r at uniform speed with frequency f. What is the kinetic energy of the particle? So, frequency. Let's convert frequency. So we've got. Well, let's do it this way around. So we can get the omega from this one. So V is going to be 2 pi f r. So the kinetic energy squared is going to be half m 4 pi squared f squared r squared. So that's going to cancel with that, leaving you 2. So we end up with what, 2 pi squared m f squared r squared, which is option C. Okay, so which one of the following graphs shows how acceleration of a body moving with simple harmonic motion varies with its displacement x? So let's have a look. What information do we have? So in a simple harmonic motion, the acceleration should be directly proportional to the displacement, but in the opposite direction. So what we're looking for is when x is positive, a is negative, but it's a straight line graph. So what we're looking for is option D here. So you can see that in positive x's, acceleration is the opposite direction, but it's a straight line showing a directly proportional type relationship. Okay, a body moves with simple motion of amplitude a and frequency b over 2 pi. What is the magnitude of the acceleration when the body is at maximum displacement? So the acceleration is going to be 2 pi f squared, and the maximum acceleration will be when it's at the amplitude. So that's going to be 4 pi squared b squared over 2 pi squared a, cancels with that, giving you b squared a. or AB squared, which is option number C, right here. An object oscillating in simple harmonic motion has time period t. The first graph shows displacement varies. Which of the subsequent graphs shows how the kinetic energy of the object varies with time? So the first thing is that the velocity graph would be 90 degrees out of phase, so would look like this. So that's your velocity graph, and you'd expect the kinetic energy graph to map the velocity graph, which is going to be option number C down here. So we can see it matches up with the velocity which I've sketched on there. So option C. Period of vertical oscillation of a mass spring system is T. When the spring carries a mass of 1 kilogram, what mass should be added to the 1 kilogram if the period is to be increased to 1.5 T? So T is 2 pi root m over k. So if we want to have 1.5 T, we have to multiply this whole expression by 1.5. Obviously it's not going to be the 2 pi that's multiplied, so it'd be 1.5 squared, and 1.5 squared equals, I think it's 2.25, but let's double check. Yeah, 2.25. So originally we had 1m, and now we've gone to 2.25 m, so we've added 1.25, and so we've got another answer C. Seems to be a bit of a pattern going on. I guess it prevents people doing guessing. The gravitational force between two uniform spheres is 3.1 times 10 to minus 9 newtons, when the distance between their centres is 1.5 millimeters. If the mass of one sphere is 2.5 kilograms, what is the mass of the other? So F is gmm over r squared. So that would mean m would be F r squared over gm. So let's do that calculation. So 3.1 times 10 to the minus 9 times by 150 times 10 to the minus 3 squared, so convert into meters, divided by 167 times 10 to the minus 11 times 2.5, leaving us with a mass of 0.418, blah 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 blah. So that's going to round to 0.42. So we finally got one that's not C. Okay, so we are on number 9. Diagram shows 2 point masses, both m, separated by a distance of 2r. What is the value of the gravitational field strength at the midpoint between the two masses? So if we think this one, the field strength is going to be acting that way, this one, the field strength is going to be acting that way. Field strength is a vector, so they obey the laws of vector addition. So since they're equal mass and they're equal distant, that's just going to mean they cancel out, giving you 0. Okay, which line A to D gives correct comparisons at x and y for gravitational potential and angular velocity? If they're both on the Earth's surface, the angular velocity is going to be the same, so we can already eliminate these. Wait, hang on, the other way around. It's eliminating these other ones, because it would have to be the same. Potential at x compared with y, so x is further away from the centre of the Earth, so it's going to have a bigger gravitational potential compared with that of y. What would be the period of rotation of the Earth needed to be if objects at the equator were to appear weightless? So this would happen essentially when an object at the equator was becoming a satellite, so it was in circular motion by itself, and so wouldn't be attached to the Earth. So what we'd have is the centripetal force would be to gravity, so let's do some cancelling. So 2 pi over t would be square root of gm over r cubed, and when we solve this, the radius and the mass of Earth are in the formula sheet, although it gives you to them there. So it'll be 6.67 times 10 to the minus 11 times 5.98 times 10 to the power 24, which is in your formula sheet, divided by 6.4 times 10 to the power 6 cubed. Square root of answer, 2 times pi divided by answer gives you 5093, divided by 60 to turn it into minutes, divided by 60 to turn it into hours, gives you something that's about 1.4. So answer B. As a comet orbits the Sun, the distance between the comet and the Sun continually changes. As the comet moves towards the Sun, this distance reaches a minimum value. Which one of the following statements is incorrect as the comet approaches this minimum distance? So we're looking for the one that's incorrect. Potential energy of the comet increases as it moves towards the Sun. No, that's wrong. The force increases. Yes, it would, because it's got closer. The direction of the force acting on the comet changes. Yes, it would, because it's always acting towards the centre. The kinetic energy increases. Yes, because the velocity decreases. So yeah, as we suspected earlier, it was indeed A. Okay, the repulsive force between two small negative charges separated by a distance r is F. What is the force between the charges when the separation is reduced to r over 3? So the force is an inverse square law, so if you third the distance, you'll times the force by 9, so that's going to be D. When the acceleration, what is the acceleration of an electron at a point in an electric field where the field strength is 1.5 times 10 to the 5 volts per meter? So what have we got here? So the force will be field strength times the charge, which is going to be that number, 1.5 times 10 to the 5 times 1.6 times 10 to the power minus 19. 2.4 times 10 minus 14 newtons, which is divided by the mass of an electron, which is in the formula sheet, and then that would give you an acceleration of 2.63 times 10 to the 16 meters per second minus 2, which is this one here. At a distance r from a fixed charge, the electric field strength is E, and the potential is V. Which line A to D in the table gives the electric field strength and electric potential at a distance 2r from the charge? So, if you double the distance, you will halve the potential. So it was V, so you'd end up with V over 2. So that's going to emit that one. And then if you double the distance, you should quarter the electric field strength. So that's going to give you option number C. Two protons are 1.0 times 10 to the minus 14 apart. Approximately how many times is the electrostatic force between them greater than the gravitational force between them? So let's think. So essentially what we're doing is a ratio of QQ over 4 pi E0 R squared over M over 4 pi E0, oh, what am I doing? G over R squared. Your R squareds are going to cancel out, giving you Q Q over G m squared, because they're both protons, 4 pi E0. So what do we have? 1.67 times 10 to the power of minus 20. Oh, sorry, we're doing the charges. So 1.63. 6 times 10 to the minus 19 squared divided by 6.67 times 10 to the minus 11 divided by 1.67 times 10 to the power of minus 27 squared by 4 divided by pi divided by 8.85 times 10 to the power of minus 12. And you end up with option number C here when you calculate it. Okay, so let's move on to the next one. The graph shows how the charge stored by a capacitor varies with the potential difference across it. Which line A to D gives the capacitance and the energy stored when the potential difference is 5 volts? So capacitance is Q over V. So when it's 5, it's 10 times 10 to the minus 6 over 5, which is 2 times 10 to the minus 6. So that will be eliminate C and D. And it'll be half QV, so 5 times 10 to the power minus 6 is 5 times 10 to the minus 5, which is 50. So it's B for that one. Oh wait, no, I forgot to divide it by 2, sorry, so it's going to be not B, it's going to be A, because remember energy is half QV. A 10 millifarad capacitor is charged at 10 volts and discharged completely through a small motor. During the process, a motor lifts a weight of mass 0.1 kilograms. If 10% of the energy stored in the capacitor is used to lift the weight, through what approximate height will the weight be lifted? Okay, so first let's find the energy, which would be half CV squared. So we've got 10 times 10 to the power of minus 3, because it's a millifarad, divided by 2 times 100, because that's V squared, gives you 0.5 joules stored. So 10% of that would be 0.05 joules. So then the height is going to be the energy divided by the mass, so divided by 0.1 divided by 9.81 would give you 0.0509. So that's option A. Okay, a negatively charged particle moves at right angles to a uniform magnetic field. Magnetic force on the particle acts. So what we've got here, we've got, well, it's a magnetic force, so it's not in the direction of the field, or opposite, it's going to end up being perpendicular. So it's not in between, it's exactly perpendicular. An electron moving with constant speed enters a uniform magnetic field in a direction perpendicular to the magnetic field. So we've got force is constant but perpendicular to the motion, so we're going to end up with a circular motion. 21. A coil of 50 turns has a cross-section area of 4.2 times 10 to the minus 3. It's placed an angle to a uniform magnetic field of flux density 2.8 times 10 to the minus 2. So that the angle is, which is given to the normal, is 50 degrees. What is the change in flux linkage when the coil is rotated anti-clockwise until theta equals 0? Okay. So when it reaches 0, the flux linkage will just be BAN, which is 5.88 times 10 to the minus 3, and the flux at the angle of 50 degrees would be that times by cosine 50 which is 3.77 blah 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 times 10 to the minus 3. So 5.88 minus that answer minus 3.77 gives you about 2.1, and it's going to increase, so that's going to be option B. Aircraft wingspan of 60 times by a speed of 150, and you've got a flux density of that. So first of all, the swept out area is going to be 60 times 150. It's the swept out area, so the area swept out per second is 9,000 meters squared per second. So if we times that by 1.0 times 10 to the minus 5, that gives you BA, so it gives you flux per second. So that's going to be 0.09, and it's done in over 10 seconds, so that's going to give you 0.9, or 9 times 10 to the minus 1. So that's going to be that one once you multiply it by 10. Like that. So 23, you've got 3 identical magnets P, Q and R released simultaneously from rest and fall to the ground from the same height. P falls to the ground, Q falls through the centre of a thick conducting ring, where R falls through one for a gap. So we're going to get some electromagnetic induction, which is going to have an effect on one of these. So P and R arrive together, followed by Q. Yes, I agree with that. That is correct, because this isn't a complete conductor, so there can't be any force from any induction going on. So P and R should arrive. Q would experience a force in the opposite direction, so its resultant force would slow down, so it takes slightly longer. So it's just going to be A. The primary coil of a step-up transformer is connected to a source of alternating potential difference. The secondary coil is connected to a lamp. Which line A to D in the table correctly describes the flux linkage and the current passing through the secondary coil in relation to the primary coil? Okay, so it's a step-up transformer, which means the voltage is stepped up, so the current is stepped down. So the secondary current should be smaller than the first, so it's going to be less than 1. So that's going to eliminate C, and it's going to eliminate D as well. If we're stepping up, that means there's more turns on the right-hand side, so that means there's a greater flux linkage on the right-hand side, so that's going to be greater than 1, so it's going to leave you with A. And final question. Transformer has 1200 turns on the primary and 500 on the secondary. We've got current on the primary of 0.25 and 240 volts, and its efficiency is 83. Okay, so the voltage on the second side is going to be a step down, so 240 divided by 2.4, so your secondary voltage is 100. The input power is going to be IV, so it's going to be 0.25 times 240, which is 60 watts. But it's going to be 83, so if you multiply that by 0.83, that's going to give 49.8 as the power out. Divide that by 100, gives you a current of 0.498, so 0.50 once we've rounded it there. Okay, so that's that paper complete.